Hi, we're here today for a brief overview of the building blocks that make up an NG-IT SmartStack Converged solution. Seen here is a typical SmartStack pod consisting of one or more Nimble Storage appliances, a Cisco UCS compute fabric, and optionally Cisco Nexus switches. The value of SmartStack is around providing a validated yet flexible reference architecture which boosts the speed and quality of deployment. Furthermore, NG-IT SmartStack customers benefit from Nimble Jet, that's Joint Escalation Team, support, which provides a single number to call for any issue with the SmartStack solution. So with all that in mind, let's take a closer look at the Nimble and UCS components. Seen here is a Nimble Storage appliance, which provides a great combination of high performance, high capacity, and advanced storage efficiency features in just 3 of rack space. Around the back of the array are 2 controllers which help provide Nimble's proven 5 nines availability. These are in an active-passive configuration. Nimble does this for a couple of reasons. One is to provide for non-disruptive operations. By this I mean the ability to upgrade the Nimble Storage OS and perform hot swaps of controller hardware. This includes controller upgrades to boost performance. The second reason is to guarantee the same level of performance even when a controller has failed. Contrast this with an active-active system, where workloads are typically presented from both controllers, and a controller failure may mean a decrease in storage system performance. On the back of our controller, we see a number of connectors. In a SmartStack, we'll typically use 4 or more 10 gig SFP ports for connectivity back to our UCS fabric. However, we also have the flexibility with Nimble to use 1 or 10 gig Ethernet, and now also 16 gig fiber channel. Around the front of the array we see internal drive bays, which contain 12 high-capacity magnetic drives and 4 SSDs. These drives vary in size depending on the needs of the customer. It is often a surprise for customers that the persistent storage layer on Nimble is made up entirely of 7200 RPM SATA drives, especially when we consider that even the entry-level Nimble array delivers up to 20,000 IOPS. This is because Nimble uses their own custom-built file system, Castle, in conjunction with high-performance Intel CPUs to first compress and then convert host writes into a sequential layout that can be written down to spinning disk very quickly. What's more, because of this IOPS abstraction layer, we're able to provide a very high level of RAID protection on these drives, that's RAID TP, triple parity, without impacting on host performance. So we provide the performance of flash, but without the associated write wear and cost associated with even the latest generation of SSDs. So what do we use the 4 SSDs in the base unit for? These SSDs are used to provide a large area of read cache, so we also get fantastic read performance. For a particularly large environment, we have the ability to expand beyond the base unit with the Nimble AFS cache expansion shelf. This allows SSDs to be added in groups of 4 above and beyond the 4 SSDs in the base unit. In addition to the optional AFS shelf shown, we can also add up to 6 capacity expansion shelves per array, allowing up to 400 terabytes raw capacity per Nimble device. Now, we've already mentioned scalability in terms of non-disruptively replacing array controllers for more powerful ones, expanding the cache and expanding capacity. We can also scale Nimble by grouping arrays together. This can simply be used to manage multiple arrays as one, or we can actually pull together capacity and performance resources from multiple arrays and present them to a VMware cluster as a single storage resource. This means up to 500,000 IOPS and up to 1.6 petabytes of raw capacity from a 4-node Nimble cluster. So let's take a look at the Cisco UCS element of the SmartStack. A Cisco UCS system typically consists of 1 or more 6U blade chassis, such as the one seen at the bottom of this image. Each chassis can contain up to 8 half-width blades. In addition, we have the UCS fabric interconnects, seen at the top of the screen. So the fabric interconnects are the foundation of the UCS stack and serve 2 main purposes. Firstly, they are the single point of management for your blade infrastructure. Irrespective of whether you have 1 or 20 chassis, they are all managed as one single logical chassis within the UCS fabric architecture. The UCS Manager management interface also runs directly on these interconnects, with no need for an external management appliance, or multiple points of management for each chassis. Secondly, the fabric interconnects provide an aggregation layer for physical connectivity to and from our SmartStack components. The fabric interconnects we see here contain highly flexible multi-personality ports, which could be used as chassis connections, uplinks to our production LAN, or for iSCSI connectivity to our Nimble Storage array. We have the flexibility to connect into a number of different customer LAN topologies, and the uplinks could be either 1 or 10 gig Ethernet. You may have noticed that the UCS chassis contains 2 I/O modules. These are purely used to aggregate bandwidth between the chassis blades and the UCS fabric. They are not a point of management. This is in contrast to other blade solutions where each chassis has its own point of management. Bandwidth between our blade I/O modules and the fabric can be easily scaled by simply adding more physical links between the chassis and the fabric. Cisco UCS Blades are based on the latest Intel CPU architecture. In the typical SmartStack blade, we use the Cisco UCS VIC, that's Virtual Interface Card, which provides up to 40 gig bandwidth back to the UCS fabric from each blade. However, up to 256 dynamic virtual NICs can be created per blade. These VNICs form part of the UCS Blade service profile configuration. Service profiles can be thought of as a personality for a blade. This allows us to pre-configure things like BIOS settings, firmware settings, and VNIC configuration purely in software. We can apply the same profile to multiple blades by using service profile templates. This makes replacing or adding blades to an ESX cluster, for example, very easy, as we can apply a service profile template to have a blade up and running in minutes. The UCS blades can contain internal hard drives. However, in a typical SmartStack configuration, blades tend to be entirely stateless. What this means is that firstly we use service profile templates to automatically apply a personality to the blade without the manual configuration required each time a traditional blade would be added or replaced. Secondly, in a SmartStack deployment we use Nimble iSCSI boot, which means the blades can boot into a hypervisor or host OS directly from the SAN without requiring internal drives. This negates the need to perform any OS reinstallation should a blade need to be replaced. All this means that we can add, replace or reprovision blades very quickly. This, in conjunction with the Nimble Storage platform, provides a highly scalable and performant foundation for a customer private cloud. Thanks for watching. Why not visit us at our website or follow us on Twitter for the latest NGIT SmartStack information. We'll also be adding new video content regularly, so check back soon or subscribe to our YouTube channel for more.